we are supporting Ferrari in powertrain development. And he's Mattia Violi, and he's CAE manager for the fluid dynamics area, so for all what concern the hot part of the simulation, let's say. And he's also manager for the AI, in which we spent a lot during the last 3 months in order to, let's say, be able to participate to this digitalization of the entire Motor Valley environment. So HPE Coxa is a union of 2 companies. The first one, HPE, is much more, okay, it works, linked to engineering services. Basically, the 2 companies are 2 different companies splitted, but let's say under the same and between the same walls. In HPE, we are following all the teams and the topics about engineering stuff, testing stuff. So we are currently splitted and divided like a sort of OEM office, big 2 office, design office, simulation office, and then we have these testing facilities in which we are able to test our products or OEM products. Then for Coxa itself is a manufacturing department in which we have a machining workshop and also an additive layer manufacturing workshop that I think was quite good to have in the last years, also for some motorsport application in which a lot of components drive into this technology. So it was a sort of new workshop facilities in which we work, let's say, 24, 25, I think, CNC center, a lot of powertrain components. Major markets that we are currently following are especially the first 2, so automotive and motorsport. We will see later on that are 70-75% of the overall turnover of the company. But there is also a big slice of highway in which we cover some products development and also defense and automation solution. I think that we need to be really agile as company because we work with all the OEM that you will see later on and that you previously see during this speech that are currently in a moment in which they are also understanding where the world is going to go. I think that the carbon neutrality is one of the major content on the future, so on the future 20, 15 years. And I think that as a minor player, we need to play a role in which we react with a proper speed, because basically we need to assess and offer a solution, technology solution to our customer. And in this moment, it's not clear to my mind the direction in which we will gonna be in the next 10 years. So I guess that it's a big challenge for them. It's maybe even tough for us due to the fact that we are in a sort of second phase and we are playing a minor role with respect of them. Okay, panel of customer really plays on the Motor Valley. Then we also work a lot for other companies, especially worldwide. We cover a lot motorsport. We will see later on the 4 major, I think, championship. So also for NASCAR, we work a lot in powertrain development. Powertrain and traction components are in somehow our core business. I think that since 2018, there was a big evolution in our company. We were really focused on endothermal engine, ICE engine. Now we have to move also to electrification. And I think that we use the same approach in which traction remain our core activities. And that's why we have developed electrical machine and products for the traction. Instead, for the other parts, ECU, inverter, and also battery, we are currently play a role in which we use partnership in order to cover the full electrical vehicle, let's say, design and engineering. Okay, this, how I was saying before, is the split of the turnover. This is an example of our product. It's I think, a product for off-highway application. It's an electric machine with a NARPin stator technology. But on this, I will go too deeply in the next slide. And yes, motorsport and automotive represent, for instance, our main, let's say, volume of workload. We are approximately at 35 millions of turnover, and as we can see in the next slide, we are 300 people that work under HP Coxa. And now we are split, yes, in the two main companies that are HP and Coxa, but we also open another business unit that was done during the pandemic COVID issue. This was to, let's say, place in the same area, in the same business unit, all the new technology. And so we put in this, for instance, simulation, because we really believe that powertrain, but also vehicle approach and vehicle development is really simulation driven nowadays. So we have an office of approximately 50 people that works on simulation. Then, obviously, electrification was a brand new technology for us. For instance, we need to understand how to play this match of the electrification, and we decided to go to products, especially for electrical machines. And also artificial intelligence was part of this new business unit that we call Evo. It's not a proper company, it's under HP Coxa, but it's just a business unit in which we split all the people that works and the stuff on electrification, simulation, and AI. The average age of our company is really pushed on the bottom side, so we are approximately at 30 years. We really believe, and I think that these situations and this talent work are helping us also to pass the message that I think that the challenge of the carbon neutrality is really placed on young generation and new generation. So we think and we really, let's say, push on having new graduates and people inside our company, because I think that also university make a lot of step during these years in evolution, also in terms of let's say, courses, training, and so on. Understand that they need to move from some, I think, aged courses towards new technology. And so I think that on youngs, I consider myself young because I'm pretty 30 years old, is placed the challenge of the carbon neutrality. So I think it's really, we really appreciate and we really push on university relationship. I've also prepared a couple of slides on it, because we think that university need to be part of our company, and the university needs to make with the companies and with the, let's say, OEM, the big step for win this new challenge. Electrification engineers are almost 30 people. We would like to see this KPI, because we think that was a huge growth during these years, because we start on 2018, as I was saying, with 0 people, and now we are pretty 30. We developed 3 brand new electrical machine. We are developing our internal inverter, so I think that there was a big step on it. Just a couple of slides in which I can show the our facilities. I think that all the other partners of this MV festival are pretty known. We are placed in Monera. Here is just a picture of 2 box lab that we decided to build in a sort of green economy and circularity sustainability, in which we place some area of confidentiality on the box that you see down on the picture, in which all the team of F1 development that I'm leading is supporting Ferrari. As I said before, we are almost 30 people that we works on, let's say, powertrain activities. And then the first box is completely dedicated to university. And as I said before, we are part of the MUNER. We have also, let's say, created an high formation school inside our company that was called Mecane. The aim of this is to, let's say, organize for all the new graduates, people that are currently coming with us, at least 4 or 5 major courses per year. These courses are really connected to some university that are partners with us, in which professors came and come to, let's say, give frontal lessons. We really believe that this approach, in which this course lasts 60 to 80 hours, is really beneficial for, let's say, bridge the gap between, let's say, the outcome from the university with the start of new graduates with a job. No? So we really think that this approach, in which we also spend a lot of investment in giving frontal and let's say courses, training courses to people, help the guys to come in this company without the main, let's say, the main gap that is obvious between the university and the corporate industries. Then we have testing facilities. We will see later on, we have 3 testing facilities for ICE powertrain. 2 are up to 1,000 kilowatt, in which we develop, calibrate durability and also other activities for, let's say, hybrid, high voltage hybrid powertrain, Ferrari, Aston Martin, and so on. We have a completely dedicated test bed for Ferrari Formula One, in which we, let's say, develop the single cylinder. That is a kind of approach in which you are trying to anticipate some development content, especially for flight dynamics content in this tool that is replicating, let's say, the V6 application in a sort of compact way with cost reduction and so on. And then we have a last test cell that is a back-to-back cell, in which we are testing our application of electric machine that was created, I think, last. Okay, workshop, as I said before, 25 CNC center. Our core activities, powertrain components. We work with aluminum, steel, and so on. And the last, I think, was this, that I think was a great investment, an assembly lab, due to the fact that for Lamborghini we are currently producing a sort of electrified gearbox for 2 production application, 2 few off, in which and this assembly lab was created to handle all let's say, the activities about this product, in which we design and develop a system that help Lamborghini with this automatic transmission to cover the torque, all given by the fact that it's not a dual clutch transmission. And so with this torque filler, low voltage, we create a sort of linearity during the exchange of the gear, and all the transmission are assembled and developed by us in this facility. Just to spend a last few slides about a project that with some professor of university I'm following, is this new, let's say, area of the company that we call Link. The aim was to, let's say, handle all these all the activities about knowledge improvement, about innovation. So we are currently placed on 4 major, let's say, activities. The first one is the relation with the university. We are partner with 5 universities: Modena, Bologna, Pisa, Firenze, Perugia, and we are part of the MUNER. The aim is to obviously spend a lot, invest money in research, invest money in PhD, invest money in master degree, in order to collaborate in a strict way with them. Open innovation, in which I think this is the basically the location of our accelerator. The aim is to handle the relationship with the startup in order to catch any opportunities to collaborate with them, to understand if there are synergical, let's say, activities that we can develop with them. Then there is the area of the training, and so all the formation plan that I spent some words before, and then sustainability, because I really think that companies like us needs to let's say, handle all this stuff to catch some investment from the PNRR in order to be competitive and develop projects, let's say, in a sort of competitive funding approach. This to me is really important just to say, and then we will go to the technical side of our job. We develop 14 profiles. That is what I was somehow pleased to show today with you, because I think that talent that are coming from university needs to understand what role and what type of profile we are currently looking for. I think we made a lot of work to understand who are the people that we really need. We develop some profiles, are 14. All the profiles are 2 years or 3 years of formation. Obviously, 90% on the job and 10%, as I said before, plays on our, let's say, training lessons. And obviously are really divided on how a powertrain company is divided. So pushed on design, simulation split on the main 4 areas that are 1D, 3D, and for the mechanical approach, obviously FEA, and on the other side, dynamics and MBH. Then we have some figure about AI that later on Mattia will share some information about what we are currently doing on it, and also about electrification and testing. We cross them with a sort of major 11 pillars that we need to follow. I think that these are the main pillars of knowledge improvement in which we have to push. So they are split in 4 major areas. Obviously, I come from POWERTRAIN and I really follow and focus on it. But there is Mattia about AI, and also electrification obviously play a big role on this strategic skill that we are currently searching on people. And we cross this profile in order to match this matrix that we use with our formation approach. So there is this plan of 3 years that people will follow once they will join with us after a master degree. Then coming from the, let's say, the best part of the speech about technical, let's say, products. So about powertrain, like the statement are saying, we are able to cover an end-to-end development from concept to validation. That means that we are able to take a white sheet and develop a powertrain like it was done for Aston Martin, like it was done for other customers. We were able to reach some deliverables starting from a white sheet, looking to the package space of the vehicle and working on a sort of development product development merged with also the vehicle development itself. We are currently handling some high performance production for small volumes. Obviously, we have now a big workshop, a really focused workshop in which we can handle production for at least 100, 200 powertrain. So it's really, let's say, numbers for motorsport application. We work, and we will see a chart later on motorsport, and I think that motorsport is our main, let's say, activity. About key facts, we are approximately 100 people that handle with powertrain. As I said before, a lot of simulation engineer merged with the design. Then we have obviously all the workshop that is fully dedicated to powertrain. The assembly lab, and when I said powertrain, is just not ICE, but it's obviously also transmission, axles, etc., etc. 3 test bed and this additive lab in which we can print different powders for different materials. Okay, sorry. Skip some slide. Okay. Just a focus about design, I think, as I said before, working on a end-to-end project is really important to cover in terms of design activity all the concept phase. I think that the approach in IC development during these years changed a lot. As I was saying before, we really believe that the simulation driven is the correct approach right now. And so we spent a lot of in concept phase in order to merge all our fluid dynamics tool with all the concept team design in order to let's say have a reliable concept phase in which numbers and let's say design parameters are coming from simulation and not from expertise. Then simulation just a pillar. Obviously, we are almost 13 ICE plus I think 15 for the electrical stuff. Obviously, the split is really equal to a common your office of IC development of the other OEM that we are working with. So basically split it in 1D, 3D. I think that a lot of knowledge that you are currently creating in mechanical or vehicle training courses during the degree are currently covering this type of application. Obviously, in simulation, it's really important to be correlated. I think correlation and revalidation after experimental data was one of the major investment on the last years. That's why we have these 3 test bed, because we think that to design and to proper, let's say, compact development, the product development phase with not a lot of experiments and with not a lot of let's say experimental phase, a long experimental phase, we need to be really careful results. Same thing for dynamics and FEA. I think are really common and standard for obviously also people that are coming from university, but we need due to the fact that we are working with a lot of customers to work with a lot of tools. This is basically the main difficulty, because obviously they are currently forcing us to align to their tool. So basically we are really, to my mind, really wide in terms of simulation activities. Then there are the 3 test bed that was describing before. I think that I spent already some words about it. The main investment during the last 2 years, the last 3 years, was to make this test bed to be, let's say, compliant with high voltage hybrid system. And so that's why we are able now to work with P2 application powertrain, or also to test in our ICE test bed some EV application in which we tested directly the electrical machine. This is a chart to mainly describe what we are currently doing for motorsport. I think that these are the 4 major activities, but for instance, there is a 5th one that is NASCAR, and I really think that their approach is really quite far from the approach of the Motor Valley. They are really based on design, make a lot of experiences, a lot of experimental phase, and they're really pleased to work with us in order to have this virtual approach that they are really far from. And the other 4, let's say, major championship that we are following are F1, in which we have this area where confidentiality and exclusivity has to be mainly the main, let's say, diktat. We are approximately 30 people working on the IC and the ER system. We have this test bed in which we develop some contents that we are developing, or contents that is developed directly by, let's say, Ferrari. And we have this dedicated machining shop, both for single cylinder and V6 components production. Then there is the same for LMH, so WIC, EC, let's say, championship, in which we are currently work with Ferrari for their future coming in LMH championship. And we start to work a lot also with MX GP. We work with Beta Motorcycle. We develop a brand new engine that will run in 2024, I guess, in 250cc engine, brand new, with also some know-how technology transfer for other fields. I think that MX and also maybe MotoGP, but are a step back, not with respect maybe to F1 application, also in terms of technology, and especially for MX, there is a lot of, let's say, improvements that can be done by companies like us that used to work with F1 engine development. I prepared a chart also for the carbon neutral roadmap. I think that at this stage, as I said before, it's difficult to understand our role. So basically, to not make mistake, in this moment we are playing a role that I used to call technology neutral in terms of attitude. So basically, we think that there could be a lot of different evolution. I think that fuel cell could be a good evolution for transportation, let's say, sector, and we are developing a POC to, let's say, assess the complete energy management and concept phase of a fuel cell for a transportation application. We think that H2 will be, and I think that there was also agreement this morning on the big round table, as I called before with Mattia, in which, let's say, CEO of OEM were saying that maybe H2 could be, with the fuels, could be a solution to avoid to lose, let's say, ICE emotionality and content. So we are developed with partners that are placed in components, let's say, development, like for injection system, for ignition system. We are developing a POC in which we are taking a proper gasoline engine. We are with high power density, so we are speaking about something like 200 horsepower per liter. We are trying to convert and transform this engine in a monofuel H2 engine, in which we can develop, let's say, combustion system, ignition system, injection system with partners. And also in the fuels, we are working with some fuel producer in order to assess and to give them feedback on the direction of, let's say, that they are following in terms of a fuel production. So we are just a sort of results assessment for them for what concerns CFD impact, both in performance and emissions. Try to go ahead fast. About electrification, I think the approach is really quite close to the powertrain. We have, let's say, we are currently cover different products. E-machines and the motors is maybe the crucial one for us. We developed 3 different technologies of e-motors. We are currently developing one SiC application, 800 voltage, in terms of CU, so inverter. And we have also developed some e-axle. I think that hybridization with P4 application will be, I think, especially in supercar and hypercar application, one of the most used one in the next, I think, 10 years, before 2030. We used to work in a different sectors. So obviously for motorsport, we are part of the developing of the MGK application for F1 application, work on super premium, so for supercar and hypercar, but also with some application, one technology was developed for let's say low speed and application much more compliant to off-road sector, and then later on also for defense. I will jump a bit fast on this slide, leaving the speech to Mattia for the AI part. So basically also in this, the approach is completely model and system based. We really think that also, especially on this simulation drive, the the development. So we used to work in a sort of model-based big tool that we develop internally, in which we can obtain all the missions for all the component development, and then later on we use this mission to develop or internally or with our partners all the components related to an EV powertrain, so for battery, inverter, and e-machine. A lot of simulation will be done also on that development. Obviously, for performance, plays on electromagnetic, let's say, field. Obviously, for thermal, which I think that CHT is the correct approach, in which you can merge 3D, let's say, CFD steady state calculation with a direct solid thermal solution. And also other simulation, if we can go ahead, about mechanical and AVH. I think that is really important for the stability of these products, that nowadays is not perfectly clear how they will work also in aging. So it's really important to properly assess from a reliability standpoint, let's say, these products. Two test bed. The first one is a back-to-back. It's clear on the right side of the picture, up to 25,000 RPM. The second one is a conversion of an ICE test bed, in which we are currently testing application at low speed, especially for off-highway transmission. In which these are the products. So three main fields. The first one is a sort of field used for off-highway application. We think that hairpin stator is the right technology with IPM rotor. The power density is not so high, so we can cover from let's say low speed and high torque, but low, let's say, ratio between kilowatt and kilo electrical machine, up to some technology really close to F1 technology, in which let's say carbon sleeve rotor with SPM rotor and this wire are currently allowing us to go up to 25 kilowatt per kilo. Last slide for me is the project about inverter that we are currently, okay, sorry, a couple of slides remained. First one is about the axle. First application is the Lamborghini one that I was saying before, the electrified gearbox, in which we developed this low voltage system for torque feeling. Then we develop a brand new, let's say, e-axle, front e-axle, with not torque vectoring. In fact, you can see just one, let's say, e-machine. Now we are developing a really high premium solution for an hypercar, an e-axle with torque vectoring, so with two, let's say, e-machines that are driving and are, let's say, technology that I was saying before, really close to the F1 one. And the last one is a completely electrified transmission that we developed for CNH, and in which we were able to integrate in the vehicle and to customize the solution with both the component development of the machine and also the transmission development. Okay, we can skip it. Leave the speech to you.
Thank you very much. So, as said before from Leonardo, HPE built a new business unit called Adivo, in which we merge simulation capabilities, AI, and electrification. Why we make AI? We make AI because we think, we believe, and the market says that we are in the right. That domain competence and analytical competencies and the knowledge of physics, coupled with informatic technologies that claim AI, permit us to fit very well the business needs and to build very interesting application of AI applied to our product. To make this, obviously, we have analytical skill, but we don't have informatical skills. So we invest a lot in two ways. One way is using our academic partnership and Mecanea to reskill some of our resources and integrate the programming competencies on it. And from other side, we identify a key partner that is Hewlett-Packard, that for sure provide us all infrastructure and GPU hardware and so on. But the main support to us is that we have the access to their laboratories. So we work with Grenoble and with USA to give to our customer the latest technologies that are in place all in the world. In terms of sector, we have a wider range respect to HPE Coxa because we for sure have automotive as one of our main sector, but we work a lot also with automation solution, pharma, and wellness. Here we try to schematize the approach in which we can proceed to build an AI application, because we want to be sure that all our customers understand that it's not something extremely complex, but it's something that approaching in a right way could be a straightforward approach that give us possibility to solve, mitigate the problem of our customer. So we build from data. Here there is the first problem, because very soon the data aren't in place, or if there is data are not completely describe the behavior of a product. So we support our customer with building a digital twin model base. So with our simulation capabilities, and with this we are able to build a virtual data set to develop AI application, and both we can build an experimental facility and a set to build also a data set constituted by experimental data. Starting from this, we identify the right approach, so the right neural network or classificator methodology. We train it, and we give the information produced by it to the business, and the business try to use it to mitigate the problem. Where we work with AI, we work on three main sectors of industry. The first is production process, to optimize the process and to minimize the anomalies of the product generated by assembly process. We work on the product, sensorizing it, and build services on it, and on business processes. So we work on financial services and after sales to help our customer to improve their process and to save money. Here I want to show some example of our application more related to mechanical side, that is our main sector. The first one is related to CNC machine, and is built both for our customer but for our internal use on suppose. And we want to integrate our CNC machine with sensor and software able to anticipate spindle anomalies and tool wear. How it works? We identify a sensor with a PCB board with microcontroller. We build a case for it, and we have positioned on CNC machine. We make a campaign to acquire data during CNC machining phase. And after that we have the data set, we we build a software that is able to process all acceleration data and to merge it with a CNC program. And this software is able, via neural network, to classify when the tool has the right vibration profile, or if a tool has a bad vibration profile that indicate that are starting to wear. So we emit a warning, and we give to our maintenance team a feedback that must manage the procurement of a new tool. And so we minimize the stop of machine and increase production rate. Another application is more related to engine application. As you imagine, on when we are going to make a race, we want to be sure that the engine that we take to the race is performant and reliable. To make sure of this, there is a long campaign of testing at home. And to support this, we simulate all the race, so Monza and so on. During race simulation, there is a lot of that occur on engine cycle, and we may experience some problem on reliability. Some of these anomaly can take to engine brake, and these take to loss of money, but also loss of time. So, to be able to avoid this type of problem, we implement an agent that in real time, aside the operator of test cell, monitor all the signal coming from the sensor and compare it with expected signal. If the expected signal predicted by neural network was different from the measured one, the system go to start a process for understanding which is the problem. And when identifies the problem, decide if the test can go on, but give a warning to the operator, or if a problem is has a high risk of severe problem to the engine, and stop the test cell. And this gave us possibility to save engine and time, and to anticipate problem to solve on the engine. Thank you.
Thank you all, guys.
Scusami, se riesci con il microfono così si sente.
Okay, I have a question on the AI side. So it's used mostly on the data analysis, and then on the data from the test, and then give to the AI, or is it used, for example, also on the development, like, for example, on the CFD and
for sure. We use for both.
Okay.
To be honest, we start from coupling it with virtual data from simulation side, and after we move to implement it also on other applications that involve experimental data. So for both.
And also on probably on the CFD, like in the image capture of the simulation, for example, it's possible to anticipate the results of the CFD simulation using the AI to...
Internally, we don't use for this. We use for optimization, but for some of our customers, we develop it that have more recurrent type of simulation, of string simulation. And so we train this methodology to reduce simulation time and also to automate the processing of result.
Thank you. Thanks.
I hope to see you in the Motor Valley, let's say, environment, especially in our company in the future. Thanks.
Thank you very much.